Thank you, everybody. Again, always a great opportunity to reconnect with the PTV users and developers, and it is really very nice. In spite of the fact we cannot meet in person, I'm really enjoying these couple of days so far, and there is one more to hear about all of the newest developments. Well, I want to talk about the Retime platform that we have been developing for now, I would say probably over the year. It goes slower than we expected. And it's about how to retime traffic signals by using Vissim. I'm sure for many of you, this is not a new topic, but we have some recent developments that we wanted to share. And of course, I am associate professor at University of Pittsburgh, but today I present on behalf of this LLC that we developed for the purpose of developing this tool. Okay, so presentation overview very briefly. I'm going to talk a little bit about our current practices and why we believe that using analytical tools is not always the best way to optimize traffic signals. I will be talking about the benefits and a little bit about also shortcomings of using stochastic simulations, a concept where this entire framework belongs. And then I'm going to just briefly touch genetic algorithms and evolutionary optimizations and how that entire concept works. And then I'll talk about cloud computing and opportunities that it brought to this whole area. And then I will probably most of my presentation will be about showing the screenshots and slides about the platform that we developed and some of the functionalities, I believe nice functionalities that are there. Actually, this would probably be much better if I had a live demonstration of how to enter this tool and what to do. But unfortunately, 20 or 30 minutes is not enough time. So I decided to go with screenshots right now and watch out for potential webinars with the PTV in future where we will have opportunity to present, to demonstrate really how to log and how to go through that tool on the web. So what is our common state of practice when it comes to traffic signal optimization? We will collect the data a couple of times per year, even if that often, and then feed into deterministic models, which are all based on a high capacity software. For a reason, that's a good analytical tool, and we've been using that method for decades. However, most of the people in big urban cities, when we talk about urban mobility and similar, are not necessarily impressed with the private transportation and want to explore other transportation modes and have lots of problems and needs to explore how traffic signals are going to work in a multimodal environment. And that's where you have bicyclists and pedestrians and public transportation. And unfortunately, none of these are very well represented in analytical models where you can optimize traffic signals. So from that perspective, as we always say, if you put a very little bit in, what do you expect? You are going to get a little bit out of the whole process. And it's almost unavoidable that when we see people do use analytical tools, that they spend a lot of fine-tuning in the field, lots of time to fine-tune their signal timings in the field. So much that sometimes what the tool outputs as the best results is so far from reality that by the time that they finish fine-tuning, it's completely a different set of signal timings. Sometimes people will use analytical tools only for cycle length. Sometimes they will not use for cycle length. So there is a very few cases probably where people could use analytical tools to optimize signal timings, deploy in the field, and everything works perfectly. With microsimulation embedded in the entire story, I think we can change actually this paradigm. And so another thing is when we use analytical models and there is so much disparity between what the model outputs and what we put actually in our field controllers, the modeling, the whole area of modeling gets this bad reputation how it's just a model, it's not close to reality. With the microsimulation, high fidelity, properly calibrated and validated models, we can change actually that narrative. So our goal here with this whole concept, Retime Online, and similar efforts that we are making is really to bring the signal control optimization to the next level and introduce the tools which are used for microsimulation to be the major engines that are going to be used to evaluate quality of signal timing plans. So far, that has been quite challenging for a number of reasons. I'm going to talk about that. But I have to notice that, you know, we move from using analytical tools for evaluating transportation alternatives on highways, on arterial streets, in so many different aspects, but we are not moving from using analytical tools for traffic signal optimization. And the question is why? We believe that's going to change in near future. So why use Vissim to optimize signals? First, you have a variety of objective functions or optimization criteria that you can select. People are not aware because this is probably the only tool which is relatively close to commercialization that can actually prove that that's possible. But you know, most of the other analytical tools will give you just 1 or 2 or 3 objective functions. With so many performance measures that can be output from Vissim, you can actually select what your objective function is going to be, even like use multiple objective functions, either in a multi-criteria optimizations or to combine them in a single criteria and then do the optimization. We're working with a field like traffic controllers. Lucas was just mentioning RBC. Whether RBC stays there or another controller replaces it, there is also a good number of manufacturers which are providing a software in the loop controllers that cannot be maybe plugged in tomorrow, but in a very near future could be actually controllers which are modified, whose parameters are modified during the optimization process. We're already working with some of the vendors to make that happen. Models can be trusted really if they're properly calibrated and validated. I'm going to show you a few slides, and I will show you that you can work so hard to calibrate and validate your analytical models. You're simply not going to overcome some of the barriers which are inherited in those models from how actually you develop analytics, and that will never go away. So there is no way that to achieve the level of outputs, quality of the outputs with the macroscopic and analytical models as you can do with a microsimulation. And I have a feeling I'm preaching here to the choir because you all know this stuff, and there is probably no need to spend too much time on this. Oversaturation, queues. You know, most of these analytical models are still building the queues in height, not in a length, and have no idea really when that queue is getting out of the left turn bay or blocking another link and similar. There is also this notion that the optimization has to be sequential when you do optimization through analytical tool, whereas here with the evolutionary algorithms, you can really optimize so many parameters at once and still within the constraints of the optimization get good solutions. Okay, so here just a slide. We recently did a study where we were calibrating both Vissim and Vistro for a network in Florida. And what you see on the right side of this chart are 28 traffic signals for which we actually had the same phasing, average phase time for an hour of simulation time from simulation Vissim and from the field. And you will see that in 95% of the cases, the difference between average phasing time for 1 hour is less than 5 seconds. It took us like really few months to calibrate and validate our Vissim model to achieve these results. But once we finished, we had a model which was essentially exactly replicating signal timing parameters for 1 chosen hour of our simulation time. Then we developed a Vistro model based on the same parameters. We spent a lot of time on a Vistro model as well. We wanted to bring it to the perfection. And just to clarify here, Vistro is one of the best tools out there, but it's an analytical tool. and there is no big difference in the sense of how good quality of the outputs it can produce when it is compared to microsimulation tools like Vissim, which is completely a different type of animal, much more powerful, etc. But what I wanted to give you here as an example, you will see on the left side of the chart 4 figures. You can see how, for example, in a bottom left figure with the different VC ratios, suddenly when we reach like over 1 VC ratio for some of the movements in Vistro, we are nowhere close to 1 in Vissim. We don't even see the similar amount of delay. And that's, again, just for certain types of movements. Now we can discuss why that happens. But it's usually like analytical tools have no ideas that, certain amount of capacity really will be enough. And that there is maybe no need to overestimate how much of delay is produced by certain types of movements in certain types of situations. You can see here also on the upper left chart how far the results were there with all of the outliers. Once we removed the outliers, there was still only like 75% of the coverage. We saw, for example, you can see in the upper right chart that some of the biggest deals were because Vistro was not aware of the delays and could not properly model delays for the phases which had a floating force-offs, which is like a feature in normal controllers that you see on a daily basis out there. You can easily model that in Vissim. You cannot model in Vistro. Vistro is not, and not just Vistro, all of the analytical tools are like that. And then right turns on red, another example, etc., etc. So signal operations really cannot be properly modeled unless you have a simulation tool and unless you have a verifiable platform that is going to mimic your field controllers. RBC is, I would say, good enough. It could be better. There are better maybe software in the loop modules out there. But I think when you compare RBC with what you get from analytical tools, there is a huge difference. And so what are the shortcomings of the Vissim simulations? Of the optimization with Vissim simulation? Long optimization time. Well, that's something that we are trying to reduce with the cloud computing to be only a couple of hours or overnight. Objective function difficult to choose, etc., etc. I need to hurry up. I have a feeling I already used more than half of my time, and I haven't even started with the major part. So genetic algorithms, again, it's a concept where you are essentially combining solutions from multiple generations. You define your population. You say, I'm going to have a 20 signal timing solutions in one population or 100. And then every generation you recombine, you leave the best for the next generation, you recombine all of the others. And similarly to how we evaluated through the history to become who we are today, we are evaluating different signal timing plans to find the best one. Now I'm going to skip these few slides where I'm talking about how important it is to have a parallel computing because of the very heavy computational burden to evaluate so many timing plans, each through a separate simulation. And that's where cloud computing becomes very handy. And that's where we actually combine our program with the Azure Cloud, where we have a virtual machines. We can have dozens, hundreds of virtual machines working at the same time. It's a matter of cost. It's not matter of technical viability. We can do it tomorrow if somebody's happy to pay the cost of the optimization process. So how this whole concept works? This is essentially software as a service, envisioned as a software as a service platform, where you go to our website, which is called Retime Online. There is a address down there. You log in with your user credentials, and then you go to the home page. And unlike most of the people who do this professionally, we developed all of the things in a backstage. We're still working on the front end. So our home page is probably the worst part of our website. You will see There is nothing out there, but it's a work in progress. But we also already got the optimization running, and it works quite well. So this is the first screen where you need to enter the name of your optimization, define your range for cycle length, define duration of simulation, define population and number of generations that you want to use, select performance measures. What is that? Performance index, number of stops, delay, whatever pretty much Vissim gives you as a performance measure as an output could be plugged in as objective function. We don't have that technicality for each one right now, but that can be easily developed. Then you also select what type of signal timings you want to modify. And we also have an option how you want to treat your pedestrians. I can go into detail some other time. I don't want to spend too much time on that right now. So next screen, you get opportunity to select your Vissim file. Right now it works with RBC controllers only. Very soon we will add other types. So you essentially need to specify your INPX and LAX files and all of the RBC controllers that you want to optimize. It is as simple as that. Then in the next screen, you get opportunity to confirm all of the files, which will be processed. And then in the next screen, you get to confirm which controllers you want to optimize. Because let's say you have 15 controllers, but you want to keep 5 as they are right now. You want to optimize only 10 of the others. You can actually select that at this stage, and it will do the optimization only for the specific controllers. Everything else will be used as is. And then how does the optimization works on a cloud? It takes a few minutes to start virtual machines. You define how many. The Vissim network is loaded. Then current signal timing plans that you have in your RBC controllers are used as a seeds to create the others. And then it kind of goes through the genetic optimization process. Not kind of, it does. And then it runs every signal timing plan in a simulation, groups of them for all of the signals, of course, finds the best, keep it aside, and then recombines all of the others, and then goes and does that for number of generations that you specified. Here, you get opportunity immediately as the process starts to see these interactive charts where you can actually, these will update automatically, and you can see how, as the optimization is going, another dot is added on the chart. And if your performance index is the objective function, you will see how the performance index deteriorates as the process goes through multiple generations. So now, once you finish the whole process, there is opportunity to do a post analysis, and you can actually go and you can see here all of the optimization that we've done in the past. For you have a list of them. You can click on any of those optimizations, and you go to this main page where you see the map with your signals. So now each of the signals is clickable. If you click on one of the signals, you get to see immediately what was your initial signal timing plan and what is your optimal or final signal timing plan. So very quickly you can compare the two, and you can see, has your cycle length changed? Is the offset different? What is happening with the splits and so on? And you get also to see the ring barrier diagrams. So in next step, I want to just to clarify here, you can also select like from the entire optimization process, which probably had like hundreds, if not thousands, different signal timing plans. You can select for each generation which generation number you want and which population number from that generation you want. You can see these two search fields circled here. And when you select actually new plan, what it's going to do, it will just keep adding plans at the bottom. So you can actually have here a whole stack of signal timing plans for that signal, and you can compare them. The other thing which is also possible to do from this screen, so you don't have to go back, you can just simply select another signal and do the similar search and do comparison of your signal timing plan from your optimization. So now if I go back to my map, I do have additional tabs, and I can select performance charts. Performance charts is essentially the one that I already had a chance to show you, but there is like a big number of them that can be pulled out at any point of time. So here are just like 4 and you have really opportunity to keep adding these charts either while optimization lasts or after, because all of the data are in the database. How long? As long as you do not run out of the performance measures from Vissim. Right now, we mostly work with the performance, with the network performance measures, but we are going to add also node performance measurements and some others. So what else
Alex,
is there?
sorry to interrupt. If you can tie it up within the next
Yes.
minute, we're a little bit over time already. Thank you.
Absolutely. So here is another thing. Sorted, you can actually find out which one is the best for each of the performance measures. Here is a Pareto chart. That is a very nice feature because you see each dot here on a chart is a solution on its own. And if you actually click on any, you can enlarge and you can see actually each dot separately. You can keep adding also as many Pareto fronts as you want. If you click on the dot, you actually get to see all of the plans which are related to that solution. And what that means is you can see actually how good that plan is in terms of the performance measures, a table of the signal timing plans, and you can see all of the RBC charts. And that's pretty much the end of presentation. I just wanted to say we still have work in progress. Is very soon we will be able to give you opportunity to download all of these outputs in different formats, like RBC format or PDF or the entire database. And the next steps for us are really to we'll probably come out with the first commercial beta version in early 2020, and we're looking for partners who are interested to apply this and in some sort of pilot projects. Sorry for running this a little bit longer than I was supposed to, and thank you for your attention.